So source is a monochromatic source or a monochromatic light. The slits are coherent sources. So what is meant by a limit of resolution? Limit of resolution means it's a distance between two objects which is to be observed. Having this equation, we have to get for bright fringes as well as dark fringes. Okay. Hello everyone, I am Brinda, Faculty of Physics from Vidhyaashram Pre-University College, welcoming you all to session 2 of chapter 10, that is wave optics. In today's class, we are going to deal with constructive interference, destructive interference and Young's double slit experiment, as well as going on to the diffraction. We'll just get the Brewster's angle. So for here, we'll end up with the topic, that is wave optics. So first of all, we have got the Young's double slit experiment. In order to deal with Young's double slit experiment, we need to know two concepts, that is constructive interference as well as destructive interference. For the constructive interference, we have phase difference delta is given by 2 times the n and it is pi. So which means to say that even multiples of pi has to be present in order to define for the constructive interference. This is for the constructive interference. Having this, we need to get the path difference. Path difference will be equal to n times the lambda. So this is the path difference for the constructive interference and it's the phase difference for the constructive interference. These are the two conditions for the constructive interference to happen. In case of constructive interference, we have the higher magnitude. Higher is the magnitude, higher is the intensity. It is getting constructed as what you have to think. Next, we are getting on to destructive interference. In case of destructive interference, which means to say that the amplitude is decreasing, which means to say that even the intensity is also going down. For that, we have the phase difference is given by 2n plus 1 times the pi is what we are considering. So it is odd multiples of the pi is what we are having for the phase difference. Whereas when we equate for the path difference having the with respect to this phase difference, then we will end up with 2n plus 1 and lambda by 2 is what we are having for the destructive interference. So, constructive interference we have n and lambda, destructive interference we have 2n plus 1 lambda by 2. These are the two conditions for phase difference as well as the path difference for constructive as well as destructive interference. For this concept, we are just keeping all these concepts as a base, we are just going to derive the Young's double slit experiment. So what was double slit experiment? It was like a source was considered a monochromatic source and two of the slits, the source light from the source was split by the slits which was present and slits were first used was the pinholes. Okay, so with the help of a pin they made a hole for a sheet and then from the source a light was being passed through those pinholes, because of which the interference pattern was seen. It was interfered, the light rays actually interfered each other, which caused the modifications when it reached the screen. But later onwards, instead of those pinholes, the slit were created in the sheet and only one source was used, monochromatic source. So suppose here is a monochromatic source which is giving the light, then we have got two types of slits, call these two slits. Before it was pinholes and nowadays they make use of the slits, okay, two cuts. So we can consider this as A and this as B, and the distance between this coherent source, so the slits, the light which is passing through the slit, so this is a monochromatic source, but this is the two coherent sources through which the source, that is a monochromatic light, is passing is known as a coherent source. In last session we had discussed about coherent as well as incoherent source nature, right? We consider a coherent source which is passing through the slit and that slits are considered to be a coherent source, understood? So source is a monochromatic source or a monochromatic light, the slits are coherent sources, okay? There is a screen which is placed on which we detect the images, that is the resultant light, okay? So now when we just name this, it's like the center of the source is said to be over here. We just mark as a center, call it as origin, it is O, Okay, so from the light which comes from the A is being given as Q, and from B it is mentioned as R. But the light is it gets distributed from the coherent source, so that at one point, some point P, we just consider this as P, from A as well as B, we need to identify what is the intensity there over where exactly the coherent sources are going and falling, and that intensity, in order to calculate the intensity over there, we need to have the certain point from A and B. It should be a common point. So the common point what we are considering for A as well as B is P. This is used to identify the fringe width. We identify the fringe width. So what are these fringes? Whenever there is an interference of light which is created, there is a band what creates. The bands can be the bright band as well as dark bands. Okay, bright and dark, like zebra marks, you will have bright, white, dark, white, dark. The intensity is more at one place and the intensity is decreased. It completely looks like a black shade. Okay, so it is completely decreased, which looks like a zebra marks. Okay, so that is all about your fringes. Okay, and the width is between two bright fringes or the width between two dark fringes is what we are just to consider, and what that consideration is done at a selected point, and that point is called as P. So these are the experimental setup what we are doing. Having this concept, we need to just get into the fringe width. So what is our question? Question is to obtain the expression for the fringe width of interference fringes in Young's double slit experiment. So we have the concept here. So that is, we have a diagrammatic representation here. Now let us forward, that is proceed with the concepts what we have to actually derive for. So now we know that the distance between these two poles is said to be D. That means the distance between two slits. Okay, D, small letter d is the distance between two slits. Capital letter D is the distance between coherent source as well as the screen, and the distance from P to O is said to be X is what they have considered. Okay, so having all this initial stuffs for the diagrammatic representation for the Young's double slit experiment has been taken place over here. So for that, let us just give, we know that the path difference between the two coherent sources as well as the point, that is, these two are the coherent sources and this is point. The path difference to travel is given by, we know that delta is equal to BP minus AP is the path difference is what we have. Consider this as equation 1. So the question arises for this double slit experiment as obtain the expression for the fringe width of interference fringes in Young's double slit experiment, and which is known as very important concept for 5 marks from this chapter. So we have delta is equal to BP minus AP. So now we need to consider two triangles, that is, one is BPR, we can consider this point. So considering triangle BPR, we have the right angle triangle thing, that is a Pythagoras theorem. Using that, hypotenuse BP square is equal to sum of square of other two sides, BR square and PR square. So we know that BP square is equal to, what is B and R? It is T square plus PR. PR square is nothing but you have X. P to O is X. And half of this is, we know that A to B is D and this is D by 2, D by 2. So OQ can be considered as D by 2. D by 2 plus D by 2 gives you just D. Half of the D plus half of the D fuses to give 1D. Okay, so we have 1D, half of it is D by 2. So I'll just go with PR is nothing but X. With that, X plus D by 2 the whole square. So we have this. So we know that BP square is equal to D square plus X plus D by 2 the whole square. Consider this as equation 2. Now just let us get into the second triangle. Call it as, consider triangle AQP. For that we have, this is one of the concept. This is one of the concept what we are actually trying for. So AP square is equal to, we have AQ square plus QP square. AQ square is nothing but the D square what you have. So from X you're subtracting D by 2. So you will get PQ. So X minus D by 2 the whole square, equation 3. So now if you just check, we know that on equating for this path difference, we have BP square minus AP square is equal to D square plus X plus D by 2 the whole square minus D square plus X minus D by 2 the whole square. So it's like BP plus AP into BP minus AP concept. On equating and some cancellations of all these things, you remain with 2x times the D. Okay, the equation is must and should. You will have to just perform the steps. That is, this is by using a plus b the whole square and this is by using a minus b the whole square. You will get some equations wherein you will cancel out each other for you to get 2xd. So now it's like we need to obtain this. So we just retain BP minus AP is equal to 2xd, and since we know that BP and AP is approximately equal to D, as well as AP. Okay, when that is the case, you can just consider this is divided by BP plus AP is approximately equal to D, means D plus T becomes 2D. So this gets cancelled, 2 gets cancelled. So what we remain with is BP minus AP is equal to X into D by D is the equation for this path length. Okay, so path length delta is equal to XD and D is the concept. Let me consider this as equation star. Okay, this is the main equation. Having this equation, we have to get for bright fringes as well as dark fringes. Okay, so now let us just check into how exactly to give for the constructive interference and how exactly to be given for the destructive interference. Bright fringes means we usually consider the constructive interference concept, and destructive interference concept can be considered for the darker fringes. For that, now if you just know the path difference, you can go with that. For the constructive interference or for the bright fringes, you know that the path length delta is equal to n lambda. So we have delta is equal to, we have xd divided by d. This is for the bright fringes. These are the conditions. Bright fringes, delta is equal to x d by t. So delta, we also know that for the bright fringes we have n lambda. So it is n into lambda is equal to x into d divided by d. Okay, so now having this, we have to equate for the xth term. Okay, so xn is nothing but nth time lambda into d divided by d is the concept. Understood? This is for the nth bright fringe, whereas when we consider for n plus 1th bright fringe, for that fringe, if you have to check, this is nth fringe. This is for the n plus 1th fringe. So it is x to the base n plus 1. It comes out to be n plus 1 lambda d by d. When we go for this, it's nothing but beta. Beta is the fringe width what we consider. So beta is equal to, you have to equate xn plus, higher is xn plus 1, lower is xn. X to the base n plus 1 minus x to the base n. For this concept we have beta is equal to, when we just equate it, we have n plus 1, and since it is minus, again minus n of common things. Which are the common things? Lambda d by d. We cancels n and n. So beta is equal to lambda capital D by small d. Capital D is the distance between the coherent sources as well as screen. Small d is the distance between the two coherent sources, that is the slits. Okay, so that is the equation for the bright fringe. This is for the fringe width for the bright fringe by using the equation for the path difference between the constructive interference. In the same way, if we just go for the destructive interference, we have delta is equal to x d by d is the concept what we have. So what is delta? 2n plus 1 by lambda by 2 is equal to x into d by d. For the nth fringe, we just go with x is equal to 2n plus 1 to lambda into d divided by, you go with 2 times the d. Okay. Similar way, for the nth fringe, we can just continue here. For the nth fringe, we have n plus 1th fringe, sorry. For that, you go with x n plus 1 is nothing but 2n plus 1 of plus 1 and lambda d by 2d is the concept, for which you can just take x n plus 1 is equal to 2n plus 3 the whole lambda d by 2d. On equating for the fringe width, finally, after equating x to the base n plus 1 minus x to the base n, you will end up with the equation beta is equal to lambda d by d. The same equations for bright as well as the dark fringes, it's both one and the same. Okay, for the constructive as well as destructive interference, you have got the using Young's double slit experiment conditions for the fringe width are both one and the same. So this is the most important formula for what you have to know, the formula for the fringe width. Okay, and this is the most important concept. As a base, you will have to carry on with the slit experiment. All these is not that important that you have to remember things. These are all the basic things whatever we have studied in a previous classes and all, by using Pythagoras theorem and by using the differences, that is path difference, and by applying for the constructive and destructive interference, for which this is important, because having this equation only we can get the constructive and destructive interference equations, and fuse both of which you can just equate, and finally you will end up with the width, fringe width. Okay, so this is one of the most important derivation. Obtain the expressions for the fringe width of interference fringes in Young's double slit experiment, which is for the 5 marks question. Okay, so having all this, let us just move to the next topic, and that is nothing but resolving power. So what is meant by a resolving power? In order to resolve the two nearly occupied particles which is present, we need to resolve it. We need to have a clear image of it and a clarity for it. So in order to have a clarity for a nearest objects, we need to have clarity for it, for which we will just involve this resolving power. Okay, we just want a perfect resolution, clarity, understood? So in order to have a resolution, it is what we call it as resolving power. So resolving power are different for microscope, it's different for telescope. Resolving power are always like, it is the reciprocal of the limit of resolution. So what is meant by a limit of resolution? Limit of resolution means it's the distance between two objects which is to be observed. That is called as limit of resolution, and reciprocal of this limit of resolution is called as the resolving power, understood? So now, ability to produce distinctly separate images of two closely point objects are known as this resolving power. And resolving power are different for two things, that is microscope has got certain resolving power and telescope has got certain resolving power. So for microscope, the resolving power is said to be 1 by d, that is reciprocal of the limit of resolution is equal to, it is 2n sine theta divided by 1.22 lambda. So this is the resolution of the microscope, which you have to remember. N can change 0, 1, 2, 3 till extends till infinite. So telescopes are having a resolving power of 1 by theta is equal to, it is d divided by 1.22 lambda. So this is the resolving power of the telescope. So these two equations is very much necessary for you to remember. Okay, these are the two important questions out of resolving power, they ask about microscope or telescope. So how can you improve the resolving power? Resolving power can be improvised with the help of either we increase the radius or refractive index of the object what actually has to be seen. So the refractive index should be increased, or the radius of the material what we observe should be increased, and the light should be of the shorter wavelength is what actually we study under the resolving power. So these are all about the main things what we have to actually remember, that is resolving power, Young's double slit experiment. All these concepts are very important. Constructive interference, destructive interference. So the session 2 includes almost all the important concepts of this wave optics chapter. Having this concept, we're just going into the Brewster's law. And what does actually Brewster's law tell? In case of this Brewster's law, we know that the refractive index, N means we know that it is a refractive index, right? So of a transparent medium, it is equal to tangent of the polarizing angle. So it might go over your head. In order to know this, we have to get back again to our ray optics and optical instruments chapter. That is, we need to know reflection as well as refraction concepts. By having that, we can just derive this equation. So we know that there are two types of conditions. So before studying this Brewster's angle and Brewster's law, we need to undergo with two types of lights. Okay, one is polarizing light, another one is unpolarized light. We have two types, polarized and unpolarized. So what are these two types of lights? Polarized light, we need to know. Polarized light means the light which have the vibrations, or it vibrates in the single plane. Whereas unpolarized light means to say that the light which vibrates in varieties or various plane. It has got different, more than one plane it starts vibrating. So the representation of polarized light will be in this manner, and the representation of unpolarized light is in this manner. So these are the two representations for polarized light and for unpolarized light. Okay, so I hope you understood the difference between this polarized light and unpolarized light. These two are the concepts what you have to know, like how exactly we have studied in Young's double slit experiment. Similar way, we need to know the polarized and unpolarized light concepts as a base. Okay, so having this as a base, we know that refraction takes place in a denser, rarer, all those mediums. Okay, reflection takes place when one object is shaded is what we consider, right? So here in this case, we study two of the concepts, reflection as well as refraction, both we study here. That means the incident ray is said to be unpolarized. Okay, so this is a normal which is drawn from denser to rarer medium. So this is N1 and N2, denser to rarer medium. So when the light rays is incident on a certain medium or the interface, when it travels into the denser medium, it moves towards the normal. So movement of the unpolarized light towards the normal is given over here in this way. So again we get the refracted ray also said to be unpolarized. But whenever the polarization is taking place over there, polarization means conversion of unpolarized light to polarized light. Converting unpolarized to polarized light is called as polarization. Very easy. So define polarization. Conversion of unpolarized light to a polarized light is called as a polarization. So what is polarized light? It is the vibration. It's a light which gives the vibration a single plane. Unpolarized light which gives the vibration in various, that is the different planes, right? So now we have studied about refraction. Refraction is over. I told you we are fusing two of the concepts. Along with this, now let us go to the reflection. So this is the unpolarized light which is falling onto the interface, and getting reflected is polarized light. So polarized light is getting reflected. Okay, so here we asked, according to the rules of reflection, we know that angle of incidence is equal to angle of refraction is concept what we study, right? So having this itself is the Brewster's law is being proved by using this experiment. Okay, so now we know that in order to have this equation, we know that incident angle is equal to angle of this polarizing concept. When r is equal to theta p, even I also becomes theta p, because angle of incidence is equal to angle of refraction, right? So theta p, theta is the angle, that is a polarizing angle, because it is getting polarized. The unpolarized light, it is falling on above the interface and it is getting reflected back with the help of an angle called as polarizing angle. This polarizing angle is also called as Brewster's angle. So this is called as Brewster's angle, because Brewster gave about the polarizing concept, right? That is why that angle is said to be Brewster's angle. So we know that angle of incidence plus angle of refraction both makes together 90 degree. We have a 90 degree concept over here. Understood? So correct to 45 division, we just draw the normal concept. Understood? So now we know that angle of incidence is theta p plus angle of refraction is equal to 90 degree is what we have. Now by using according to Snell's law, we know that sine of angle of incidence to the sine of angle of refraction is equal to a constant, right? So now having this, sine of angle of incident is what? Sine I is sine into theta p by sine refraction R is 90 minus theta p. So it is 90 minus theta p. Together it gives, we have sine theta p divided by sine 90 minus theta p is cos theta p. So we know that sine by cos is equal to sine theta by cos theta is tan theta. So sine theta p minus cos theta p, it becomes tan theta p, which is equal to n. Therefore, we have n is equal to tan theta p. So what is Brewster's law tells? It is refractive index n is equal to tangent of the polarizing angle is what we have proved by using this concept as well as this representation. So that is all about the Brewster's law. Law tells that refractive index of a transparent medium or a medium is equal to a tangent of the polarizing angle. So that this is a very important concept, the law as well as what is meant by Brewster's angle as well as the equations. Okay, so in today's class we have dealt with Young's double slit experiment with the help of a constructive interference and destructive interference, and furthermore moving forward we have got the fringe width in the same concept, and then we have studied about the resolving power, the two equations, one is for microscope and one is for telescope. With that I told you what is meant by a limit of resolution, and then forwardly we have dealt with polarizing angle, polarization, types of polarization under which we have polarized light and unpolarized light. So converting the unpolarized to polarized is called as polarization, and along with that we have got the Brewster's angle and Brewster's law we have derived. That's all for today. Let us all meet in the next class. Until then, have a good day. Thank you.